Hi, engineers. Struggling with those tricky coding interviews for QA or SDET roles? In today's video, we're diving into 3 essential JavaScript challenges that'll sharpen your problem-solving skills and boost your confidence. Finding the longest common prefix in strings, calculating the length of the last word, and efficiently merging sorted arrays. Whether you're a beginner or brushing up, I'll walk you through each one step by step with clear explanations, code breakdowns, and tips to nail them in real interviews. Let's level up your coding game, so stick around till the end. Let's solve another classic interview problem, finding the longest common prefix among an array of strings. So here's the problem. Given an array of strings, return the longest common prefix string. If there is no common prefix, return an empty string. Let's rephrase it in plain English. A prefix is just the beginning of a string. For example, in the words flower, flow, and flight, the common prefix is FL. If we look at dog, race car, and car, there is no common prefix at all, so the answer should be an empty string. First, let's set up our example inputs as variables so we can reuse them in tests. We create S1 equals an array of flower, flow, flight. Then, we create S2 equals an array of dog, race car, car. Then, we create S3 equals an array of interstellar, internet, and internal. And the last one, we create S4 equals an array of apple, apricot, and ape. How do we solve it the basic way? One simple idea is to assume the first word is the prefix, and then compare it with every other word. We keep trimming the prefix until it matches all words. If, at some point, the prefix becomes empty, we return an empty. Here's the code for the first solution. We create a function named longest common prefix that takes one input named SDRS. Inside the function, we write an if statement. If SDRS length equals 0, we return an empty string. Next, we declare a variable prefix and set prefix equal to SDRS at index 0. This is our candidate prefix. Then, we create a for loop, with I starting at 1 and running while I is less than SDRS length. This loop checks every other string against prefix. Inside the for loop, we create a while loop with the condition that SDRS at index I does not start with prefix. Inside the while loop, we update the variable prefix. We set prefix equals prefix slice from 0 to prefix length -1. This removes the last character from prefix. When the while loop finishes for this string, it means the current string starts with prefix, so we continue to the next string. When the for loop finishes for all strings, we return prefix. All right, now let's test the first solution. We write a console log of longest common prefix of S1. Then, console log of longest common prefix of S2. Then, console log of longest common prefix of S3. And the last one, console log of longest common prefix of S4. Expected results for the first solution is FL for the first one, empty string for the second, INTER for the third, AP for the fourth. All right, now let's create an optimized approach. Instead of trimming a candidate, we can check the characters column by column. This is called vertical scanning. We compare the first character of each string. If all match, we move to the next character. We stop at the first mismatch or when we reach the end of one string. Everything before that index is our common prefix. Here's the code for the optimized solution. We create a function called longest common prefix that takes one input, the array named SDRS. Next, we write an if statement. If SDRS length equals 0, we return an empty string. We create a variable first and set it equal to SDRS at index 0. This is our reference word. Then, we create a for loop with index I, starting at 0 and running while I is less than the first length. This will check each character position of the first word. Inside this loop, we create a variable char and set it equal to the first at index I. Next, we create another for loop with index j, starting at 1 and running while j is less than SDRS length. This loop compares char against the same index in the other words. Inside this inner loop, we write an if statement. If I is greater than or equal to SDRS at index j length or SDRS at index j at position I does not equal char, then we return the first substring from 0 to I. This is the common prefix so far. If the inner loop finishes without a mismatch, we continue to the next character index, I. If the outer loop finishes completely, we return first. And if we finish the loop without a mismatch, we return the first word itself. Alright, now let's test our optimized solution. We write console log of longest common prefix of S1, then console log of longest common prefix of S2, then console log of longest common prefix of S3, and finally, console log of longest common prefix of S4. Expected results for the optimized solution in the same order. FL for the first one, empty string for the second, INTER for the third, and AP for the fourth. Let's solve another classic interview problem, length of the last word. Given a string S consisting of words and spaces, return the length of the last word in the string. A word is a maximal substring consisting of non-space characters only. Let's rephrase it in plain English. We take the sentence, ignore any spaces at the end, find the final word, and report how many characters it has. First, let's set up 3 example inputs so we can test them later. We create a variable named S1 as code crack rocks. Then, we create a variable named S2 as keep it simple with extra spaces at the end and in the middle. And finally, we create a variable named S3 as edge cases are fun with a few spaces at the end. So, how do we solve it the beginner way? We trim the string to remove leading and trailing spaces, split it into words, and take the last one's length. This is simple and very readable. Here's the code for the first solution. We create a function named lastLen that takes one input named S. Inside this function, first we declare a variable named parts and set parts to S, trimmed, and then split by 1 or more spaces. Then we look at the last word inside parts, count its characters, and return that number. Good. Now, let's test the solution with our variables. We write a console log of lastLen of S1, then a console log of lastLen of S2, and a console log of lastLen of S3. When we run the file in the terminal, the expected results in this order should be 5 for the first one, 6 for the second one, and 3 for the third one. Now, let's create a more advanced solution with constant extra space. We will scan from the end of the string. First, we skip any trailing spaces. Then we count characters until we hit a space or the start of the string. The count we collected is the length of the last word. Here is the code for the advanced solution. We create a function named lastLenScan that takes one input named S. Inside the function, first we declare a variable named I and set I to S, length -1, so we start at the last character. Then we create a while loop that runs while I is greater than or equal to 0, and the character at S at I is equal to a space. Inside this loop, we decrease I to skip trailing spaces. Next, we declare a variable named len and set len to 0. Then we create another while loop that runs while I is greater than or equal to 0, and the character at S at I is not equal to a space. Inside this loop, we increase len by 1 and decrease I by 1 to count the characters of the last word. After the loop finishes, we return len. Now, we test the advanced solution with the same variables. We write a console log of lastLenScan of S1, then a console log of lastLenScan of S2, and a console log of lastLenScan of S3. When we run it, the expected outputs are the same as before, 5 for the first one, 6 for the second one, and 3 for the third one. Let's tackle one of the most common interview problems, merging sorted arrays. We'll keep this practical and beginner-friendly, then step up to the optimal approach. Today, we'll write 2 solutions line by line, the simple glue and sort, and the classic 2-pointers. We'll finish each with quick console checks and a short complexity note so you can say it confidently in an interview. Let's say the problem out loud. We are given 2 arrays, both already sorted in non-decreasing order. Our job is to merge them into one sorted array. Imagine two tidy lines of numbers. We are weaving them together without breaking the order. Let's rephrase it in plain English. We look at the front items of both lists and always take the smaller one first. We keep doing that until one list runs out, and then we append whatever is left from the other list. Simple and predictable. First, let's set up 3 example inputs so we can test later. We create a variable named A1 as the list of 1, 3, and 5, and a variable named B1 as the list of 2, 4, and 6. Then, we create a variable named A2 as the list of 1, 2, and 2, and a variable named B2 as the list of 2 and 3. And finally, we create a variable named A3 as the empty list and a variable named B3 as the list of -3, 0, and 7. How do we solve it the beginner way? We take both arrays, glue them together, and sort the combined result numerically. This is fast to write and easy to explain, but it is not the most efficient. Let's create a function named mergeSortedSimple that takes 2 inputs named A and B. We will return a new sorted list. Inside the function, first, we create a variable named combined and set it to A concatenated with B. Next, we sort combined with a numeric comparator. We write a sort that compares 2 numbers x and y by returning x minus y. That forces numeric order instead of string order. Finally, we return combined. Now let's test this beginner version with our variables. First, we write a console log of mergeSortedSimple of A1 and B1. Next, we write a console log of mergeSortedSimple of A2 and B2. And finally, we write a console log of mergeSortedSimple of A3 and B3. When we run the code in the terminal, we should see 1, 2, 3, 4, 5, and 6 for the first one, 1, 2, 2, 2, and 3 for the second, -3, 0, and 7 for the third. Complexity for this version: time, O of n plus m log of n plus m because of the sort, space, O of n plus m for the new array. Now, the approach most interviewers want to see. We will use the classic 2 pointers technique. It is fast and stable. We keep one index for each array. We compare the current elements, push the smaller one into the result, and move that array's index forward. Because both arrays are sorted, the smallest overall element is always at one of the 2 heads. Doing this in one pass keeps the final array sorted. Here is the solution, line by line. Let's create a function named mergeSorted that takes 2 inputs named A and B. We will return a new sorted list. Inside the function, first, we declare a variable named I and set it to 0. I points to our current position in A. Next, we declare a variable named J and set it to 0. J points to our current position in B. After that, we declare a variable named result and set it to an empty list. This is where we will push merged values. Now we start the main loop. We create a while loop with the condition I is less than A length and J is less than B length. This means both arrays still have items to compare. Inside the loop, we write an if statement to compare the current elements. If A at index I is less than or equal to B at index J, we push A at I into result, and then we increase I by 1. Otherwise, we push B at J into result and increase J by 1. We use less than or equal for stability. Equal values from A will appear before equal values from B, preserving original ordering for ties. After the main loop finishes, one of the arrays is fully consumed. We might still have leftovers in the other array, so we add 2 small cleanup loops. First, we create a while loop with the condition I is less than A length. Inside it, we push A at I into result and increase I by 1. Then, we create another while loop with the condition j is less than b length. Inside it, we push b at j into result and increase j by 1. These loops append any remaining elements. Finally, we return result. That is our merged, sorted array. Let's test the two-pointer version with the same variables. First, we write a console log of merge sorted of A1 and B1. Next, we write a console log of merge sorted of A2 and B2. And finally, we write a console log of merge sorted of A3 and B3. When we run the code in the terminal, we should see 1, 2, 3, 4, 5, and 6 for the first one. 1, 2, 2, 2, and 3 for the second. -3, 0, and 7 for the third. Quick complexity note, you can say out loud. Time, O of n plus m, where n and m are the lengths of the two arrays. We touch each element once. Space, O of n plus m for the output array. If an interviewer asks for in-place merging into a pre-sized first array, mention a three-pointer variant from the end. Write the larger tail first. Otherwise, this result array version is the clean, beginner-friendly answer most interviewers accept when no in-place constraint is stated. Tiny edge case checklist. Either array can be empty. The cleanup loops handle that. Duplicates are fine. Less than or equal keeps ordering stable. Negative numbers are fine. Comparisons work exactly the same. Wrap up. Solution 1 is the beginner, glue, and sort. Quick to write, slower due to sorting. Solution 2 is two pointers, linear time, steady, and predictable. Once you can narrate, compare heads, push the smaller, advance the pointer, then append the tail, you can code this live without stress. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.